All right, this is the fourth FRQ for the 2013 BC exam. So they gave the graph of f prime, and they tell us where we've got horizontal tangent lines. We've got them at 1, 3, and 5. So horizontal tangent, horizontal tangent, horizontal tangent. So they're telling us that the slopes there are 0 exactly. They gave us the areas and the regions, which is kind of nice. And then they tell us that f of 8 is 4. All right, so now they want us to find all values from 0 to 8 where there's a local minimum, and they want us to justify the answer. So a local minimum or a relative minimum is going to come where the graph, the derivative, f prime, where it switches from a negative value to a positive value, because that means that the original graph was decreasing and then increasing. So there's only one spot where it switches from negative to positive, and that is at an x-coordinate of 6. So I'm going to say there's a local minimum at x equals 6, and that's because f prime switches from negative to positive. All right, part B, determine the absolute minimum value. So we're doing the extreme value theorem. I have to consider the left endpoint, the right endpoint, and then whatever the relative minimum was. And so the left endpoint was 0. The relative minimum is at 6, and there's only one relative minimum in that graph because we already looked for that. And then the right endpoint was 8. So for me to find f of 6, I haven't figured it out yet. Okay, so first to find f of 0, I'm going to say f of 0 plus the integral from 0 to 8. Is what would give us f of 8. And we know f of 8 is 4, so then if I want f of 0, I'm just going to take f of 8 and I'm going to subtract the integral from 0 to 8. So I had f of 8, which was 4, and I'm subtracting off the area from 0 to 8. So if I subtract off the area from 0 to 8, that's positive 2, positive 6, negative 3, and positive 7. So 8 minus 3 is 5, plus 7 is 12. So I've got 4 minus 12, which is negative 8. All right, and then for f of 6, I'm going to say f of 6 plus the integral from 6 to 8 is what gives us f of 8. And so to find f of 6, I'll go ahead and do f of 8 minus the integral from 6 to 8. So that's 4, and I'm subtracting off the area from 6 to 8, which is an area of 7. And 4 minus 7 is negative 3. And then from the given information, I already know that f of 8 equals 4. All right, so my absolute minimum value is negative 8. Okay. Part C, they want to know where the graph is both concave down and increasing. So I know that the graph is increasing when the derivative is above the x-axis. So that means if I'm looking for where the original graph was increasing, I'm looking at this part right here. And then to look at where it's concave down, that means that the derivative itself is decreasing. So this would be concave down. This would be concave down, and that's it. So, and this is concave down, but it's not increasing. So I'm not looking at that part. So I'm just looking from 0 to 1 and 3 to 4. So for part C, I'm going to say my answer is the interval from 0 to 1 and 3 to 4. And the reason for that is that f prime is positive and decreasing, which means that f would be concave down and increasing. Okay, and then part D says that g of x is f of x to the third power. And what they want us to do is find the slope of the tangent line of g at 3. So they want us to find g prime of 3. Okay, so first I said g prime is 3 times f of x squared, so I'm doing the chain rule, times f prime of x. And then g prime of 3 is 3 times f of 3 squared times f prime of 3. All right, so f of 3, they told us, is -5/2. And then f prime of 3, this is the graph of f prime, so f prime of 3 is 4. So I've got 3 and then -5/2 squared, and then f prime of 3 is 4. You could leave it at that, or you could keep going. I get 75.